Welcome to today's explainer. We're going to take something that looks, well, kind of like an intimidating alien language, complex exponents, and we're going to translate it into a really logical, highly satisfying toolkit that you can master step by step. If you've ever stared at a fraction floating up there in the exponent spot and felt a sudden wave of panic, hey, you're in the exact right place. We're going to deconstruct these formulas together, so let's get into it.
So let's look at exactly what's at stake here. The material we're decoding today directly tackles Syllabus Objective 1.2 for the CXC CCSE Math module on number theory and computation. But listen, this isn't just about passing a test, right? It's really about unlocking a fundamental rule of numbers that you'll use in algebra, calculus, and honestly, way beyond. To make this fun, we're treating this explainer exactly like a video game. Here's our map for today. First up, the key laws. Then, level 1, unit fractions. Moving on to level 2, general rational exponents. After that, level 3, the negative twist. And finally, level 4, the boss battle. All right, section 1, the key laws. Before we face any real challenges, we've got to grab our ultimate cheat sheet. Now, what's really interesting about these laws is that they hold the master keys to the entire worksheet. We've got 4 simple laws acting as a sort of universal translator. They'll literally convert any scary exponent into basic roots and fractions. So you don't need to memorize 100 different problems, you just need to understand these 4 specific rules. Once you do, every single problem becomes totally solvable. Let's break them down one by one. Okay, moving right along to our foundation, let's see how this builds with Section 2, Level 1, Unit Fractions. So, the most basic rule you absolutely must know, your starting point, is that a fractional exponent with a 1 on top is really just a secret code for a root. That denominator, the n at the bottom of the fraction, it's simply asking you to find the nth root of your base number. So a 1 over 2, that means a square root. A 1 over 3, that means a cube root. Remember, it is absolutely not division, it's a root. Let's apply this. If we look at practice problem number 1 from the worksheet, we've got 49 to the power of a half. Step 1, we just translate that power of a half into a radical sign. It simply becomes the square root of 49. Step 2, we compute it. We just ask ourselves, okay, what number multiplied by itself gives us 49? And that brilliantly illustrates our first final answer, a clean, simple 7. See how that works? Just by translating the fraction into a root, all that complex math totally disappears, and it leaves us with a straightforward arithmetic question. Boom! Level 1 cleared. Section 3. Now that we've mastered the basics, we're ready to step it up. Welcome to Level 2, General Rational Exponents, where we finally add a numerator to the mix. So, what happens when your exponent is a full fraction, like, say, 3 over 2? Well, it's actually pretty simple. The denominator still tells you the root. That hasn't changed at all. But now the numerator tells you the normal power to apply right afterward. Think of it as root first, power second. Basically, you make the number smaller by taking the root, and then you make it bigger by applying the power. Let's look at example 1, 25 to the power of 3 over 2. The absolutely crucial point here is just breaking this down into logical steps rather than, panicking. The 2 in the denominator means we find the square root of 25 first. That gives us 5. Then, the 3 in the numerator means we take that 5 and cube it. So 5 times 5 times 5. Boom! Our final answer for level 2 is 125. We took this really complex notation, 25 to the 3 halves, and made it completely manageable just by reading the denominator and numerator like a simple 2-step instruction manual. Pretty cool, right? Moving to section 4, we've got our fractional powers down cold, so it's time to literally flip the script. Welcome to level 3, the negative twist. Now, it's super vital to contrast these concepts, mostly because our brains often see a minus sign and immediately think, oh, subtract. But in exponent land, not quite. While a positive rational exponent deals purely with roots and powers, a negative sign is literally just a physical instruction to flip your number into a fraction. It just means take the reciprocal. As the rule clearly states, an expression with a negative exponent is immediately rewritten as 1 over the base to the positive exponent. Basically, the negative sign does its job by flipping the number downstairs into the denominator, and then, poof, it disappears. Applying this to example 3 from our source, we've got 27 to the negative 1/3. We're just going to follow the instructions piece by piece. First step, the negative sign drops that 27 under a 1, so we get 1 over 27 to the 1/3. Next, if we remember level 1, a 1/3 power is just a cube root, right? So we take the cube root of 27, which gives us 3. Finally, we just substitute that 3 right back into our denominator.
Following that structured path leads us right to our final answer of 1/3. It's that easy. You handle the negative by creating a fraction, and then you just solve the exponent part normally down in the basement of that fraction.
All right, section 5. All your skills have been leading up to this exact moment. It is finally time for level 4, the boss battle of fractional bases.
I want you to really think about this for a second. We know a negative power flips a whole number into a fraction by putting it under a 1, right? But what on earth does it do to a base that is already a fraction? I mean, how do you put a fraction under a 1 without making a giant, messy double fraction?
Well, the answer is actually beautifully simple. In fact, it's one of my favorite math tricks. The negative exponent just flips the base fraction completely upside down. It literally just swaps the numerator and the denominator. Once you flip that fraction, the exponent becomes positive, and you can solve it normally just by distributing the power to both the top and bottom numbers.
Let's defeat example 5, our final boss, 16 over 81, all to the power of negative 3 over 4. Okay, step 1, we use that negative sign to invert the fraction, carefully turning it into 81 over 16 to the positive 3/4. Just like that, the negative is gone. Step 2, we distribute that 3/4 power. Since the denominator is 4, we take the 4th root of both 81 and 16, and that gives us 3 and 2. Step 3, we apply the numerator, which is 3, by cubing both numbers. So 3 cubed is 27, and 2 cubed is 8.
And there it is, folks. We have officially conquered the boss battle with a final answer of 27 over 8. What looked incredibly complex at first glance was really just 3 simple rules stacked on top of each other: flip, root, and cube.
To prove how powerful this step-by-step translation method really is, just look at how fast you can now mentally solve these practice exercises from the worksheet's final sections. Ready? 64 to the 1/3? That's just the cube root of 64. Boom, 4. 32 to the 3/5? The 5th root of 32 is 2. 2 cubed is 8. 36 to the negative 1/2? The negative drops it under a 1. The half means square root, 1 over 6. See? It literally becomes an absolute reflex.
You see, math at this level isn't really about raw computing power. It's about pattern recognition and step-by-step translation. The next time you see an alien-looking equation, don't freeze. Just ask yourself, what is the secret code trying to tell me? Keep practicing these rules, and I promise you won't just be surviving math class, you'll be speedrunning it. So, what other impossible-looking problems are out there just waiting for you to translate them? Thanks for leveling up with us on today's Explainer.